Oh, good morning, dear students. My name is Ferhan Mazher, and today is 26th March 2021. Today, the subject we are studying is Physics 5054, and today we have set our hearts to solve October November 2013 Physics 5054 2-1 Section B. In this session, we will be doing the section B of this paper. Section A of this paper we will do in another video. We are doing today a theory paper and we call it paper 2. Let's start. So, October, November 2013 to 1, and we will do it section B. Let's go to the section. Section A we will do in another video. Okay, so this section B that starts from question number 9. So that is our first question, which we will be solving. Figure 9.1 shows a skydiver of mass 70 kg falling towards the earth at constant speed, a long time after jumping from an aeroplane. Let me reduce the size. At the time t is equals to 0, he receives a radio signal. He opens his parachute 12 seconds later. Figure 9.2 is the speed time graph for the skydiver. So here we have the speed time graph. Let me increase the size so you can see it more clearly. So this is the speed time graph on your screen. State the difference between speed and velocity. The first question which is coming on your screen is state the difference between speed and velocity. It's a 1 mark question. You know the speed is a scalar quantity, while the vector velocity is a vector quantity. Scalar quantities are those quantities which are defined by their magnitude only, whereas the vectors are those quantities which require magnitude and direction to completely describe them. So speed is a scalar quantity, while the velocity is a vector quantity. Okay, so let's go to the next part. It says the gravitational field strength G is 10 newtons per kg. Calculate the weight of the skydiver. You know, the weight of the skydiver is question, and we know that the mass of this skydiver is 70 kg. It's given in the question. The mass of the skydiver is 70 kg, and they want us to find out the weight. It's a 1 mark question. You know, the formula for the weight W is equals to mg. We know the value of the m, that's 70, and we know the value of the g, that's 10. Just multiply and you will get the answer. Here, you know, I've done this on a paper. Let me show you my work. It says W is equals to mg. So W is equal to 70 into 10, and W will be equals to 700 Newton. So the weight of the parachutist is 700 Newton. So let's go to the next question. Let me check the marking scheme as well. Okay, so on your screen, you can see the marking scheme and speed, A part, the second B, first part we have done. The weight is 700 Newton. Okay, so now let's go to the next part. The next question is the state the size of the air resistance acting on the skydiver between t equals to 0 and t equals to 12 seconds. So we need to find out the from t0 to t 12 seconds. You can see the speed is constant. You can see this, the speed is constant. Can you see this? The speed is constant from time 0 to time 12. When the speed is constant, the resultant force is 0. When the speed is constant, the resultant force is 0, um, which means that the downward weight and the upward air resistance, both these forces are equal to each other, and the resultant force is 0. That's why the acceleration is 0. That's why the speed or the velocity is constant. So it means that The weight and the air resistance should be equal to each other. We just calculated in the last part that the weight of the parachutist is skydiver is 700 Newton. So the air resistance will also be 700 Newton. It's very simple. Just a conceptual thing that the air resistance should be equals to the weight. For the period between the t equals to 0 and the t equals to 12 seconds, determine the speed of the skydiver. So he wants us to find out the speed of the skydiver. I can increase this size. The speed of the skydiver from 0, this much. This is the speed, and I can tell you here, the speed. Speed is how much? You see this these are 10 small squares. They are representing from 40 to 60. So here I will have 50 here. 1 2 3 4 5. So it is 50, 52, 54. So the speed is something like 54 kilometers meters per second. So the speed should be 54 meter per second, and you will write this thing here, 54 meter per second. So the speed of the skydiver is 54 meter per second. Let me check the marking scheme. Yeah, the marking scheme says 54 meter per second. So we are good. Now, the next thing, the distance fallen by the skydiver. This distance fallen by the skydiver in from T0 to T12 seconds. It's very simple, we have just, we know that uh, I can find out the area under the speed time graph. Area under the speed time graph up till 12 seconds is a kind of rectangle. So just find out the area under the speed time graph that will represent the distance traveled. Area under the speed time graph will represent distance traveled. So up till here, it's kind of rectangle. So you can find its area very simple. I have done this. Let me show you. I've done this on a paper. Let me show you that the area under the speed time graph is equals to it's a rectangle, length multiplied width. The length is uh, 54, and that's the on the y-axis, and on the x-axis 12. Just multiply them. 54 multiply 12. It will give you 648 meter. 648 meter. So 648 meter. Let me check the marking scheme. Is this right? Yes, you can see here 648 meter. So hopefully you understand that how we have calculated the distance traveled, area under the speed time graph. Then he says the change in the gravitational potential energy of the skydiver. I know now the how much drop he has in these 12 seconds. And I can find the gravitational potential energy. The formula is very simple, mgh. The change in the gravitational potential energy is equal to mgh. We just have to put the values. Let me show you my work, and let's increase this to 100%. Okay, so now let's go. Okay, now you can see on your screen that I can find out the potential energy. That's mgh. So m is 70 kg, and the g value is 10 newtons per kg, and the height which he has fallen is 648 meters. So just put them, multiply them, and the final answer will be 4.5 expo 5 joules. 4.5 expo 5 joules. So I hope that you understand that how this formula is used in finding the gravitational potential energy. Okay, so let's move to the next part. And in the next part, he says, as he falls at constant speed, his gravitational potential energy changes into another state and another form. State the name of this other form of the energy. Whenever a body is moving with a constant speed, so his energies are converted into thermal energy. This is one fact which you should always remember, that if the body is moving with a constant speed, his energy is converted into thermal energy. So because he was falling down, so initially he has the gravitational potential energy. So that gravitational potential energy is converted into thermal or heat energy. Let me show you my answer. So here we have my answer. So the gravitational potential energy will convert into heat. So let's check the marking scheme. What the marking scheme says. Yeah, the gravitational potential energy, and our last question is good, and becomes heat, thermal energy, internal energy, not kinetic energy. You cannot say kinetic energy. Remember that. If the body is moving with a constant speed, you cannot say the kinetic energy. Okay, so let's move to the next question. The next part is E part. It's a 2-mark question, and state and explain what happens to the air resistance as the skydiver opens his parachute. You see, when he was already moving with the constant speed, and his speed was something like 54 meter per second. He was moving with that constant speed, and then he opened his parachute. So before opening the parachute, his weight and the air resistance, they were equal to each other, and then all of a sudden he opens his parachute. When he will open his parachute, his surface area will become very large. So the amount of air resistance after opening the parachute will be immense. It will be more than his weight. So when he will open his parachute, the air resistance which he will receive, and that will be more than his weight. So there will be a resultant force in the upward direction, because the air resistance is more than his weight. The weight is acting downward, the air resistance is acting upward. So when the air resistance is more than his weight, so the resultant force will be in the upward direction, but the body is moving downward, and the resultant force is in the upward direction. So an acceleration will be produced in it, but that acceleration will be negative. We call it deceleration, because the resultant force, when the resultant force is opposite to your direction of the motion, it acts like brakes. It decelerates you, it slows you down. So uh, so I think I have discussed the E first and second both parts, but the question was state and explain what happens to the air resistance as the skydiver opens his parachute. This first part, its answer is simple. You see, when he opens his parachute, his surface area becomes quite large, and due to this, he receives the air resistance he receives increases. And the second part is state and explain the effect on the motion of the skydiver of opening the parachute. So when he opens his parachute, because he's receiving a lot of air resistance, his air resistance is more than his weight. So he will have, and the air resistance direction is upward. He's falling downward. So the resultant force will be upward. The acceleration will be in the upward direction, because the acceleration is in the opposite direction to the motion of the body. So it will be deceleration basically, and the body will start slowing down. It will act like brakes are applied. So it will slow down him. Let me check my answer. I have written the answer. Okay, so the 9E first part, when the parachute is opened, surface area becomes very large. So the air resistance experienced by the body will also become larger. So in the question number 9E second part, air resistance becomes larger than weight. Resultant force is in upward direction, opposite to the direction of motion. Deceleration will be experienced, and speed of body will gradually decrease, and the speed of the body will gradually decrease, and the speed of the body will gradually decrease. I hope you have understood this, and let me check the marking scheme, what the marking scheme says. Okay, so he says for E first part, they say that the 1 mark is for saying that air resistance increases, and 1 mark is for telling that this happens because of the larger area of the parachute. And E second part, skydiver decelerates, slows down, 1 mark for this thing, and net force is in the upward direction. That is 1 mark is for telling this thing. So I hope that you have understood the answers, you have understood the description, and now we are looking at the marking scheme also. So I believe that you will be able to write a very good answer which can secure you full marks. Okay, so let's move to the next question. Next part, I mean, by the t equals to 15 seconds, his parachute is fully open. State and explain what happens to the air resistance after t equals to 15 seconds. You see, after t equals to 50%, just let me show. So this is 15 seconds here. So you can see that speed is gradually decreasing, decreasing, decreasing. Okay. At approximately 28 seconds, the speed becomes constant. After that, the speed becomes constant. So his question is basically what happens to the air resistance. So you see after t 15 seconds, the speed is slowing down. The speed of the skydiver or the parachutist is slowing down. He's slowing down. So when the speed will slow down, the air resistance which is acting on that skydiver, that will also decrease because his speed is decreasing. The air resistance depends upon your speed. If you will slow down, the air resistance acting on you or the air resistance experienced by the skydiver will decrease. Let me read you my answer and then we will check the marking scheme also. So here we go. Air resistance is decreasing due to the deceleration. Air resistance at the end becomes equal to the weight. At approximately 28 seconds, the body started falling with the constant speed, and the reason will be that the air resistance and the weight have become equal to each other. Resultant force is zero. So because the speed of the body is decreasing, so the air resistance acting on the body will also decrease. So let's check the marking scheme. Let's see what the marking scheme says. F part, air resistance decreases, speed decreases. 1 mark for telling that the air resistance is decreasing, and 1 mark is for telling that the speed is decreasing. So my dear student, this was question number 9. Let me show you once again. So you can see the whole question. This was the question. Today we are doing October, November 2013 to 1. And in this video, we are doing it section B. We have just completed question number 9. And I just want to show you the whole of the question. I hope that you have hard copies of your papers with you. And if you have the hard copies with you, then it will be very good for you because we want you to see this video and write your answers in your booklets. So we are done with the question number 9. Okay, so we are moving to question number 10. A student goes for a walk in the mountains. During a storm, she sees lightning strike a hillside in the distance. Several seconds later, she hears the thunder caused by the lightning. Explain why she hears the thunder several seconds after she sees the light. You see, the thunder and the lightning, and they are produced at the same time, but they are happening on a distance, and we believe the speed of the light is very fast, and the light and the flash of that light will reach the observer very quickly, immediately, because the speed of the light is 3 expo 8 meter per second. Very fast, very, very fast, beyond your imagination. So the light will reach to him immediately. But the sound, its speed is very slow. Its speed is just 330 meter per second, or maybe 300 meter per second, 320 meter per second. So the sound will take time to reach him. So that is the reason he sees the lightning first, and he hears the thunder after some time. The reason is that the light is traveling at a very high speed, whereas the sound is traveling at very low speed. The speed of the light in the air is 3 expo 8 meter per second, whereas the speed of the sound is just 330 meter per second. So I have written this answer. Let me show you my answer. Oh God. it is not that clear. Let me increase the size. I don't know whether this is clear to you or not. Speed of the light is 3 expo 8 meter per second, while speed of thunder, which is a sound, is only 330 meter per second. Light will reach her immediately, while the sound will take time to reach her. So I think you have understood, and you will be able to find. Okay, so here on your screen, you can see the marking scheme. Question number 10A, first part. Speed of the sound is much less than the speed of the light. Accept the quoted values also. This is a 1 mark question. I hope that you will be able to write this answer perfectly. So, A second part, the question is, the student knows the distance to the hillside. She waits for lightning to strike the hillside again. Describe how she can determine a value for the speed of the sound in the air. You see, it's very simple. If she has a stopwatch, when she see the lightning, she should start the stopwatch. And when she hear the thunder, she should stop the stopwatch. And we know that she knows the distance between the hillside and her, so she knows the distance. And from the stopwatch, she knows the time the sound took to reach her. So if you divide that distance with that time on the stopwatch, she will get the speed of the sound. Very simple. So let me show you. It's a 2 mark question. Let me show you. I have also written this answer. Okay, so now you can see this is also increase the size and then make it big. You see, question number 10A, second part. She can use a stopwatch to find the time lapse between seeing the lightning and hearing the thunder. By dividing the distance between observer and hillside, by the time she can find the speed of the sound in air. So it's a simple answer. Hopefully you have understood. Let me check the marking scheme. What the marking scheme says. Marking scheme is a 2 mark question. A second part. Question number 10. Measure the time delay between the lightning and thunder. Divide the distance by time. So you get the full 3 marks. It's a 2 mark question basically. So hopefully it's clear to you. Now we are moving to the B part. After the storm, the student sees a rainbow. State the speed of light in the air. The speed of the light is 3 expo 8 meter per second. Then he says calculate the wavelength in air of the light of frequency 7.5 expo 14 hertz. We know the frequency, that's 7.5 expo 14 hertz. And we know the speed also, that is 3 expo 8 meter per second. And we want to find out the wavelength. The method is very simple. You know, V equals to F lambda. V equals to F lambda. So apply that equation. I've done this on a paper. Let me show you. So here we go. Let me increase the size so you can see this. So the speed of light is 3 expo 8 meter per second, and the V equals to F lambda. So it will be 3 into 10 to the power 8 equals to 7.5 into 10 to the power 14, and lambda, if you make the lambda alone, this 7.5 expo 14 will go downstairs on the other side. You just enter this thing in the calculator. 3 expo 8 divided by 7.5 expo 14 equals to, and the answer will be 4 expo minus 7 meter. 4 expo minus 7 meter, or in other words, we say 4 into 10 raised to the power minus 7 meter. I hope that you have understood this numerical. Let me show you this, the marking scheme also. Okay, so here on your screen, you can see the marking scheme of the B first part and second part. 4 expo minus 7 meter is the right answer, sir. Let's move to the next question. He state the colors of the spectrum in order of increasing wavelength. Do you remember that code word, very famous code word for the colors of the spectrum? We say Roy G. Biv. Roy G. Biv. RoyGBIV. Roy G. Biv. Let me show you. I've written also, and I hope you can see this. It says Roy G. Biv. Roygbiv. Red, orange, yellow, green, blue, indigo, violet. Red, orange, yellow, green, blue, indigo, violet. Okay, so C part of the question number 10. In a laboratory, the student sends blue light into a glass prism placed on a sheet of paper. The arrangement is shown in the figure 10.1. So this blue light is entering into this prism, and from here it is emerging. And his question is, the blue light enters the prism with an angle of incidence of 45-degree. On the figure 10.1, mark the angle of refraction in the glass and label it at R. So here, this is the angle of refraction, this angle, and you will write here R. I have done this on a paper also. Let me show you my work. Okay, so let me show you this. Can you see this prism diagram? So here you can see that here I have written R. Here we have written R. This is the angle of refraction inside the prism. Hope you are able to see it. So the student wishes to determine the angle of refraction on the sheet of paper. She draws the path of ray, takes in the glass. Describe how she could do this. Very simple. You see what you will do. You will take a white paper, put it on a drawing board. You will put the prism like this. You will mark its boundary, and you will remove the prism at the and this left face, the line you have drawn on the paper. On the middle point, you will draw a normal, and you will then again put the prism on this boundary marked on the paper, and then you will take a torch who's giving out the blue light, and uh, the blue light will strike here. And suppose this angle is 45. You will mark the position of the blue light, and from here you will see the blue light will be emerging from the other face of the prism, from the right face of the prism. So on the paper, mark 2 points on this emerging light ray. Then remove everything. So uh, draw a line here where the light was incident till it touches the face of the prism, and this emergent ray where you have marked 2 points, join them until you reach the face of the prism. So here where the incident ray touched the prism, and here the point where the emergent ray emerges, join them with each other. Okay, with a pencil. So this is how you trace the path of the light inside the prism, and you increase this normal and check what is the angle between this refracted ray inside the prism and the normal. It's a 2 mark question. I have also written this answer. Let me show you my answer. So let's see what can you understand. So on your screen, the answer which I wrote is a bit longer. You can reduce its size, but for understanding, we have written a longer answer. Place prism on a white paper. Mark its boundaries. On left boundary of the prism, at the midpoint of the AB, the left side, I'm calling it AB, draw normal at the midpoint. Direct blue light on the point M. Mark the position of emergent ray on the right side, which is BC, on the paper. After removing prism from paper, join the M and N M is the point where light entered prism, and N is the point where emergent ray emerged. Mn is the path of the light in the prism. So hopefully this will help you a little bit, and you can also write a better answer. So let me show you the marking scheme. He says he says for the 2 marks, he says mark or determine entrance and the exit points. For example, trace the ray back to the glass. Draw line between entrance and the exit point. So wherever the light entered and from where the light emerged, join them, those points with each other, and that will give you the refracted ray. And from that light, from that refracted ray, you can check the angle between the normal and the refracted ray, and that will be the angle of refraction. Next part is the third part. State the formula that relates the angle of incidence I, the angle of refraction R, and the refractive index N. Very famous formula. N is equals to sine I divided by sine R. N is equals to sine I divided by sine R. I run this on a paper. Hopefully this is visible to you. So sine I divided by sine R equals to N. It's a famous formula which relates the refractive index, angle of incidence, and angle of refraction. We also call it Snell's law. Okay. The second is the angle of refraction is in the glass is 28 degree. Calculate the refractive index of the glass. You know, from the given diagram, I know the angle of incidence, and I now know the angle of refraction in the glass, and I can find the refractive index. The refractive index is represented with the N. N is equals to sine I divided by sine R. I've done this on a paper. Let me show you my work. So hopefully you can see this numerical done here. So I, angle of incidence is 45 degree, angle of refraction is 28 degree, and so N is equals to sine 45 divided by sine 28, so that will be 1.5. So the refractive index value will be 1.5. So the student sends a ray of red light to the glass prism along the same path as the blue light. On the figure 10.1, mark the path taken by the red light after it enters the prism. Okay, I have done this on a paper also. Let me show you the path of the red light. Okay, so this diagram, you can see the blue and red light, they enter the prism. So once they entered at the left face of the prism, when they will enter into the prism, the red light and the blue light will be separated. You know, the red light, it will be deflected less as compared to the blue light. And when they will exit on this side of the prism, the right side of the prism, the red light and the blue light, they will be different, and they will be separated, I mean, and the red light will be deflected less. Okay, so in here, so above you will get red color and below you will get the blue color. So this is how you have to draw a ray for the red light. I hope you have understood. So let me check the marking scheme because we have done. So N is equals to sine I by sine R. That's the first part. Second part, the value should be something like 1.5. Okay, and correct direction of the refraction at both faces. Complete correct above blue. Above blue. Okay, so we got full marks, I think, if you follow this. Now we are moving to the question number 11. Here we go. Question number 11. An ammeter, a variable resistor, and a 4 ohm resistor are connected in series with a 6-volt battery. A cathode ray oscilloscope (CRO) is connected in parallel with 4 ohm resistor through a switch. Figure 11.1 in the circuit is the circuit diagram. Remember, this is something like potential divider. This is R1, which is a variable resistor. This is a fixed resistor. It is R2. And from R2, I'm taking the signals to the CRO. So it's like kind of V out. And the voltage of the battery is 6 volts. So it's like a potential divider. The circuit is exactly like a potential divider. The switch is open, okay. He says the variable resistor is adjusted so that it has a resistance of 8 ohm. Calculate the current measured by the ammeter. You see what they have done? They have made the R1 equals to 8 ohm. So R2 is 4 ohm. So their question is how much current is coming from the battery. You know, the current coming from the battery, we can find, this is a series circuit. So in a series circuit, very easily you can find the current coming from the battery. That is equals to EMF of the battery divided by the total resistance of the whole circuit. Current coming from the battery is equals to the EMF of the battery divided by the total resistance of the whole circuit. So we know that the R1 is 8 ohm, the R2 is 4 ohm. So we can easily find out the resistance. The total resistance will be 12 ohm. And we know the voltage of the battery. The voltage of the battery is 6 and the total resistance is 12. So I is equals to EMF divided by total resistance. That will be 6 divided by 12. And you will get the answer 0.5 ampere. I have done this on a paper. Let me show you. Okay, so let me show you. Okay, so here we go. So the current coming from the battery is equals to the EMF of the battery divided by the total resistance of the battery. So EMF is 6 and the total resistance is 12 ohm. 8 R1 is 8 ohm and R2 is 4 ohm. So the total resistance will be 12 ohm because they are connected in the series. So 6 by 12 0.5. 0.5 ampere is the current coming from the battery. So the ammeter will show 0.5 ampere reading. So hope you have understood this. Let me show you the marking scheme as well. So you can see the first part, the answer is 0.5 ampere. So A first part, question number 11, A first part, the answer is correct, 0.50 ampere. Now the second question in the A second part, the potential difference across the 4 ohm resistor. So you see, so how much voltage will be here is, if you remember, the equation of the potential divider. So the V out is equals to R2 divided by R1 plus R2 multiply voltage of the battery. Let me show you. He wants how much voltage is here. So I can find it very easily. I've done this on a paper. Let me show you my work. So here we go. So the V out, which is fed to the CRO, that is taken from the second resistor, and I can find the V out. Very simple formula: R2 divided by R1 plus R2. R2 divided by the total resistance multiply the voltage of the battery. So R2 is 4 and R1 is 8. So R2 is 4. So multiply 6. So it will be 4 divided by 12 multiply 6. So it will be, the final answer will be 2 volt. So the reading on the CRO, the voltage to which are fed to the CRO, that is 2 volt. Let me check the marking scheme. Yeah, here you go. Question number 11, A second part, the answer is 2 volt. The resistance of the variable resistor is adjusted until the potential difference across the 4 ohm resistor is 5 volts. So the V out is now 5 volt. So he has decreased the resistance of the variable resistor. So let's see what happens. State the effect that this adjustment has on the current measured by the ammeter. You see, if you want the V out here to be 5, here the previously here the V out is just 2 volts, and now you want the V out to be 5 volt. So you have to reduce the resistance of this variable resistor. So when you reduce its resistance is fixed, But when the resistance of this variable resistor will decrease, the resistance of this whole circuit will decrease. When the resistance of this whole circuit will decrease, the current coming from the battery is supposed to increase. You see, the current coming from the battery will increase and the ammeter will show a larger reading. That's what I think. And he says the resistance of the variable resistor, the resistance of the variable resistance needs to be decreased. Let me show you my answers. For the B first part, he says the current measured will increase, and I can show you. His question was, let me check the statement of the question clearly. The resistance of the variable resistor is adjusted until the potential difference across the 4 ohm resistor is 5 volt. State the effect that this adjustment has on the current measured by the ammeter. Now the current coming from the ammeter is the same current will be flowing through the R1 and the same current will be flowing through the R2. I know the resistance of the R2, I know the voltage drop of the R2, so I can find out the current in the R2. So I will be equals to V divided by R. V divided by, I have done this on a paper also, let me show you. You see here I have done this, I is equals to V divided by R, so 5 volt and the resistance is 4, so it is 1.25 ampere. So the current measured will increase. Previously, I think how much was the current? Let me tell you. The current was just 0.5 ampere. And now it is 1.25 ampere. It means that the current flowing in the circuit has increased. And the simple logic is because the total resistance has decreased. And now the question is, what is the resistance of the variable resistor? You know, from the battery, there is 6 volts coming from the battery. The EMF of the battery is 6 volts. If the 5 volt is taken by the constant fixed resistor R2, if it is taking 5 volt, then how much volt are left for the variable resistor? 6 minus 5, 1 volt. And the current which is flowing through the variable resistor is 1.25 ampere, because the same current will be flowing throughout the circuit. So very easily I can find 1 volt divided by 1.25, so 0.8 ohm. So the variable resistance will be 0.8 ohm, and we know that this resistance has decreased actually. Previously the resistance was more. It's a little tricky question. It is a tricky question, students. Now, let me check the marking scheme. Okay. Marking scheme says that the current will increase and it will become 1.25 ampere, and the resistance of the variable resistor will decrease or it will become 0.8 ohm. Okay, question number 11. We are done with the B part. Okay, question number 11, C part is on your screen. The trace on the CRO is a horizontal line across the middle of the screen, and the potential difference across the 4 ohm resistor is still 5 volt. The Y gain control is set at 2 volts per centimeter and the switch is closed. State the effect on the trace of the closing the switch. You know that the because it's a DC current and its value is 5 volt, has 5 volt. So on the CRO screen, from the mean position, it will be either above or below. Suppose it's above, it will be like a horizontal line. And how much up it went? Because it's not 5 volt. So 1 centimeter is representing 2 volt. If the scale is given here, you see, the Y gain control is set. Okay, the scale is given to us that 1 square will be representing 2 volts on the y-axis, but we have 5 volts, so it will be 2.5 divisions above the mean position, or you can say it will be 2.5 squares above the mean position. So, the trace will be a horizontal line. It will be 2.5 centimeter above the mean position. I've written this answer on a paper, and let me show you. Trace will be a horizontal line 2.5 squares, or you can say 2.5 divisions above the mean position. It can be either above the mean position, or it might be 2.5 squares or divisions below the mean position. You see, let us check the marking scheme. It says moves up or down, or 5 divided by 2, or it moves up or down by 2.5 centimeter. Either it will be above the mean position, a horizontal line, or it will be below the mean position. Then the next question, C part, is uh, D part, sorry. Figure 11.2 shows the figure 11.2 shows the outline, shows in outline the basic structure of a CRO viewed from the side. So this diagram is basically a diagram of a CRO. On the figure 11.2, write in 5 empty boxes the names of the parts of the CRO indicated. So we have to name them. I have done this on a paper. Let me show you. So on your marking scheme, I think this is showing on your screen. So this thing is called filament. These plates, they move the beam of electron up and down. We call them Y plates. These two plates, these two plates, we call them X plates. They control the the horizontal, from left to right and from right to left motion of the beam of electron. We call them X plates. This is the electron beam, and this is the gas tube. This is anode. Anode is a positive electrode, and it is at a very, very high voltage. It's positive, it's anode, and then we have this anode, and here we have the fluorescent screen. Fluorescent screen, or if you can say, it's coated with the zinc sulfide, and when the electrons strike with this, that portion starts glowing. So I hope that you have understood that how we have labeled this diagram, and you will never forget this, hopefully. Okay, so let's move to the next question. And it says, explain how the electron beam is produced. You know how the electron beam is produced. You see this hot filament, it's hot. It gives out electrons. From this hot filament, electrons are given out, and we call this process thermonic emission. And when the electrons are here in the air, by the process of thermonic emission, then we have an anode here. Anode is a positive electrode, and it is at a very, very high voltage. This anode is at a very high voltage, and because it is positive, the electrons are negative. So what will happen? It will attract those negative electrons, and a beam of electrons will produce. And we have a hole in the anode, so the electrons which are attracted to this anode, through that hole, they go beyond this anode, and they make a beam of electron. So I hope you have understood what I'm just describing. I've done this. I've written this also on a paper. Let me read my answer, and then we will see the marking scheme. From heated filament, electrons are emitted by the process of thermonic emission. A node at very high voltage is placed in front of hot filament. Negative electrons are attracted to the positive electrode or positive anode. So this is how the beam is produced. I have also described it, and this is how I have written it. Let me check the marking scheme. What the marking scheme says filament heated thermonic emission, 1 mark for telling this, and thermonic electrons attracted by anode or repelled by the cathode, 1 mark for telling this. So I hope that you will be able to write this answer in your own words, and now you know the two main points which should be included in your answer. Okay, so The next question is explain why the tube of the CRO must be evacuated. Why we remove all the air from it, or we try to remove all the air from it? Because we have a beam of electron. If the air is present, so what will happen? The electrons will collide with the molecules of air, and they will lose their kinetic energy, and they will stop, and they will not reach the fluorescent screen. And sometimes when they will collide with the molecules of air, so what will happen? They will be deflected, and they, instead of going straight, they will be deflected due to the collision with the air molecules. So to avoid all this, we create vacuum. We remove all the air from the glass tube in the CRO. I've written this answer also. Let me show. If air is present in the CRO, electrons will collide with air molecules, and they will lose their kinetic energy, and they will also be deflected. So hopefully you understand what I'm saying. Let me show you the marking scheme. What the marking scheme says. Marking scheme is on your screen to prevent otherwise collisions with the air molecules, to allow to reach the screen, or to the screen, to avoid deflection. So hope you have understood this. So the next question. So the next question on your screen is, in the CRO shown in the figure 11.2, the electrons travel from left to right. Explain why the flow of electrons is an electric current. The electric current means the flow of charges. The electric current means the flow of charges, because the electrons have charge on them and they are moving. So we will call it an electric current, because electrons have charge and the flow of the charges is called electronic, and the flow of charges is called current. So let me check my answer. Here you see on your screen the answer is showing electrons are charged particles and flow of charged particles is called current. Electrons are charged particles and flow of charged particles is called current. Let me check the marking scheme. Electrons are charged. In the marking scheme, you only says electrons are charged. Okay, so the next part, state the direction of the conventional current due to the electron. You see that if the electrons, you see here, the electrons are coming out of the filament and they are going to the screen. So it means they are from left to right. The electrons are going from left to right, and the direction of the conventional current will be from right to left. Direction of the conventional current will be opposite to the flow of electrons. It will be from right to left. Direction of the conventional current will be from right to left. From right to left. So by this question, we have reached the end of this paper. Let me show you the marking scheme once again. Backwards or towards the back, or opposite to the electron motion, or to the left, or from the right. So we are done with this. And my dear students, today, we have completed so in this video, we have done October, November 2013 Physics 505421 paper. In this video, we have done only the section B of this paper, and hopefully this video is helpful to you. I have done my best that try to explain the concepts and the questions, and we have also tried to write the answers, and we have also tried to explain you the concept through the discussion, and to be more and more near to the correct answer. We have also used the markings. We have shown you the marking scheme. Hopefully this video will be helpful to you. So everybody, thank you very much, and kindly, if this video is helpful to you, kindly recommend this video to your friends. And if this video are helping you in your paper practice, and they are helping you to prepare you for the Cambridge exam of O levels. Kindly like my video and also comment and ask your friends to subscribe to my channel, because when you will subscribe to my channel, it will be a big help for me. So thank you, and this is also an energy boost for me. So thank you very much once again, and have a good day.